Now, a couple of things about what always gets students' attention is to talk test. You hear test, your ears just perk up. The test, as I've said before, is going to be a collection of problems, 3 larger problems, 1 small problem, or the appetizer, and then a whole bunch of multiple choice. What could the multiple choice be? In the next couple of weeks or so, I'll post old tests. Some professors don't like their tests out in the wild. I'm the other way. I want all my tests out in the wild. Because if you look at all my tests, I call that study. So it's a little bit odd for some professors, but not for me. But there's the other thing. The multiple choice is a collection of multiple choice questions that I put together. It takes to test your basic knowledge and understanding of the material, such as, is it possible to have a positive velocity and a negative acceleration? That's not rhetorical. Positive velocity, negative acceleration. Yes. As an example, you can throw a ball up in the air. Velocity is up, positive, acceleration is down or negative. If it was coming down, does the velocity and acceleration have the same sign? If it's coming down, is the velocity? It does. Because if the ball is coming down and acceleration is down, they have the same sign. If acceleration and velocity are in the same direction, is the object speeding up or slowing down? If velocity and acceleration are in the same direction, is it speeding up or slowing down? It's speeding up. So if velocity is this way, acceleration is this way, I'm accelerating. If acceleration and velocity are in opposite directions, am I speeding up or slowing down? You're slowing down. There's a new word. I introduced 2 new words. One you've heard before, one you haven't heard before. You're all familiar with parallel. And those are obviously, you've got 2 lines in the same direction, or they don't meet. But in physics, we have a new term, parallel. The vectors, the lines or arrows, the arrows are pointing in the same direction. So if you have parallel, this is called anti-parallel, where again the lines don't meet, but they're in opposite directions. That's how we differentiate between lines where they never meet, but in one case they're in one direction or in the same direction, in the other they're in opposite. So if velocity and acceleration are opposing each other, it slows down. If they're with each other, it speeds up. Okay. The equations that we will use, and this is kind of the game plan for the next 2 weeks, is we will be covering 1D motion and then vector addition and then 2D motion. And then once we get to closer to finishing up 2D motion, I'll tell you what we'll do right before the test. And to keep talking about the test, just to give you an idea of how does the professor look at the semester. If you've got week 1 and you've got dead week or week 14 at the end and then finals, I divide it into 3 blocks. Each of the blocks has 2 sub-blocks. I call it rush and review. then rush and review. Rush and review. So what we're going to do for the first 3 weeks, and we're already in the middle of week 2, we may go into like the first Tuesday of the 4th week, I think, is we just dump out all the information, we get the basic problem sets out, and we just kind of rush out with what I've set to cover for that period. And then I believe physics is a lot like concrete. You pour it out and you got to let it set for a week. We take 5 to 7 days, not off, but exclusively recovering that material so that it sets in a little bit. And then we have test 1 between the 2 blocks. And then we do the same rush and review again for test 2. And then test 3. And then the final week, test 3 is the Thursday of week 13. And then week 14, we just prep for finals. There will be no new material. There's not really going to be a lab. Once we're done with that lab, that final lab in week 13, we're effectively done. So what we try to do is, it does seem like you're drinking from a fire hose for a couple of weeks, and then we back off for a week, and then we test, and then we do that 3 times, review. So that's the plan. When we are working with 1D motion, we are really beginning our idea that how I think of physics 213 is it's the same as problem solving 101. You could call it like applied algebra. One of these days, probably at the end of the semester, I will read for you the most hateful, spiteful, bad review I've ever gotten. Oh, it was venomous. It's delicious. But in the review, she said, and what I'm going to do is I'm going to read it, and then I'm going to respond to it. In the review, she said that, oh, I don't know if it's a he or a she. In the review, they said that all physics 213 is just applied algebra, and she made it to sound like it's a bad thing. And my response is, well, duh. Physics 213 is for a group of individuals, the vast majority of which will will never be physicists. There is a subset of Physics 213 students who choose to become Physics BA students, and their intent, the main purpose of Physics BA degrees is it's a pre-med degree program. Like, it is, what it does is it differentiates yourself from the countless biology and chemistry majors who are going into the pre-med. Physics typically will get 6 or 8 a year BA who apply to med school, and pretty much all of them get in. It makes you different. Physics is kind of hard, so if you can survive physics and organic chemistry, you're doing well. But for Physics 213, for exercise science, you guys are going into biomechanics. For the pre-meds and for the pharmacy students, what this class does, or do, I don't know, it's not English, I don't care. But its purpose, in my opinion, is to give you skills that you can learn to other classes. Make you think in different ways. Organic chemistry is power memorization, and that is a useful ability. But what physics requires you to do is to just think outside the procedure, to understand the general way things work. In a way, Chemistry is you learning how to catch a specific fish. Physics is more about the generalized idea of how to catch fish. And that, in a way, in my idea, is way more useful. So with problem solving, you have to ID the information given to you. And what I'll do is, let me write a quick problem. You launch a ball into the air. It rises, stops, and comes back down. Its motion looks like this. Now, the problem that I've decided to do, really what happens is like you've got your hand over the ledge of the cliff. And so when you throw the ball up and take your hand away, the ball goes up and it comes back down, and it has impact right there. So I need to give you information. One of the things, again, that students just freak out is that the professors are there to trick them. This is not the first time that I've ever taught this class. The days of me making just insane errors in problem design to put on a test, those are long gone. And what we're going to do over the next couple of weeks is teach you the techniques on how you can interact with me in a constructive way during a test. There are good questions to ask, such as, are we supposed to know the height of the cliff? And an answer may be, no, I'm not going to give you that information. Or I would go, oh, I'm sorry, the height of the cliff, we'll say this height here, let's make it, I'm going to call it, why not, is 100 meters. So I'm going to give you that information. If I said I'm not going to give you that information, well, that opens up a whole different chain of problem solving. But this is the first problem that we're really going to play with, so we're going to keep it simple. And another bit of information I'm going to give you is the initial velocity, which I will say is 30 meters per second. So the question that I have is, and I'll call this the valley floor. I want to know total time of flight. I want to know the velocity, moment before impact. I also want max height, above floor. I also want time of max height. So there are two types of problems within this main problem. We have the moment from launch to the top of the curve, to the moment that its velocity in the vertical is 0, and that we have the moment of the ball, the moment before impact. Basically, the motion that we're studying is this. That's what we're going to do right now. There are 2 points, well actually 3. There's the initial point, the point at which it's launched. The second point, the top of the curve. The final point, the ground. So what you need to do is begin visualizing what's going on. What happens? The ball launches up, it comes to a stop, it comes back down, it goes to the floor. Just understanding and being able to describe in English what's going on helps you understand the problem. The first thing that you got to do when you look at this and go, got to think to yourself, what kind of problem is this? It's a one-dimensional motion problem. It's not moving to the left or right, it's only moving up or down. I wouldn't dump a two-dimensional motion problem on you at this point. We're going to wait another week. So we got to keep it simple. So it's a one-dimensional motion problem. If it's a one-dimensional motion problem, it's a lot like you're gonna hang a picture on the wall. Ooh, I'm gonna hang a picture on the wall. What do? Well, I'm gonna need a nail and I'm gonna need a hammer, so I'm gonna go to the toolbox and grab the nail and the hammer. In a one-dimensional motion problem, the tools that you have are the basic equations for motion. They are, for position, y equals y naught plus v naught y t plus 1/2 ay t squared, and v y equals v naught y plus ay t. Now I included the subscripts because we're dealing with the y-axis, the vertical axis. In one-dimensional motion, it's okay not to use them, those particular subscripts. You could write it as y equals y naught plus v naught t plus 1/2 a t squared, because if you've already identified it as a one-dimensional motion problem, it's unnecessary to differentiate it by saying y, because there's nothing else to differentiate it from. So position and velocity are most likely going to be the equations that you use. In my class, when you're dealing with motion in 1D or in 2D later, these are the first 2 equations you put down on your page. Always, always. But I read in the book, Dr. Eschenberg, that there are actually 5 equations. Don't think about the other 3. These are the only 2. And why is it? Because I appeal to your sense of laziness. I call it efficiency. Which is a harder thing to do? Memorize 5 or memorize 2? I'd much rather memorize 2. So these are the 2 equations that I want you to know. Know them backwards and forwards. Now, yes, on the test, I'm against students bringing in a note sheet full of equations. What I do is I give you an equation sheet with all the equations and constants. Now, there are things like you're a human if you don't know what an area of a square is, we got issues. If you don't know basic geometric shapes, you should understand. Sphere, cylinder, cube, rectangular object. I call it the Helmholtz rule. There was one particular summer where the 213 students said, but we don't know basic shapes. And I'm like, fine, this will be the last class I give basic shape information. But when I go to my doctor, I'm going to ask her for the volume of a cylinder. And if she gives me the right answer, which she did, no one else in all of humanity taking Physics 213 will be given that information. She got it. Granted, she was kind of slow, but because I asked her, it's like, I've got a question. And she's like, you can talk to me about anything. And I was like, oh, really? Anything? What's the volume of a cylinder? And she got it. So and that was after 20 years of 20 years after leaving med school. So if she can do it, you can too. So the basic shapes you need to know, but those two will be on the equation sheet. They will not be labeled as Dr. Eschenberg's favorite equation of motion for position, and equation of motion for velocity. But what they will be is they'll be presented and you are to identify them and use them properly. So for something like this, you ID the information that you're given. What do we know metaphysically certain about this problem? I know the initial velocity. I know the height of the cliff. I know where it begins, top of the cliff. I know where it ends, bottom of the cliff. I know I'm on the planet Earth. Now let's talk about the planet Earth for just a moment. When I was in high school, I was a gravity zealot. I was a purist. I was like, gravity has to be always negative 9.81 meters per second per second. And yes, that is correct. In some ways, my naive self, I would go back in time and just slap him upside the head and have a conversation with him. The thing that you need to understand is in my class, once again, this is not accounting, this is not some math course, it's physics. I don't care about numbers. What I do care about is your understanding of the motion of particles and such. So the value of G that we will use in this class is 10. Why am I using 10? Because 10 works so well when you're trying to do math in your head. Try to take 9.81 and divide by 4. Take 10 and divide by 4. That's a lot easier. So I do this for you. It simplifies things. It streamlines it. When you start doing more problems, you'll see the advantages of this. Now A, and in this case, A sub y, is going to be 10 meters per second per second. Now G, I think of as the magnitude of gravity, or the magnitude of acceleration, if we're going to be really acceleration. Once again, my handwriting. One of the things I've learned from the very beginning, the first lecture I ever gave, it was a pure PowerPoint presentation. And what do PowerPoint presentations do? Puts students to sleep. And so what I do is I encourage student involvement by basically, I'm doing this with you guys. The downside is my handwriting's not perfect. I make spelling mistakes. It's on paper, so I can't just wipe it out like on a whiteboard. So it's got a downside, but I think in the end it works the best. And for this problem, what we're going to do is we're going to say that acceleration in the y direction is -10. Let me tell you why we pick -10. In this type of problem solving, pick an origin. You've got to pick a place that is where everything else is referred to it. If I had picked this water bottle as the origin, everybody is on that side of the water bottle. If I said, if this is the origin, everybody over here is to the left of the water bottle, everyone over here is to the right of the water bottle. So you need a reference point. There can only be one reference point. You can't have two origins. Two origins would just mess things up. So pick something sane. There really are 3 points where I would consider legitimate locations for origins. One is a little less sane than the other 2, and that would be the starting point, the top of the curve point, and the impact point. So those are typically the most common. You can pick a point somewhere in the middle, but that would be frightening. So I'm trying to help you. Could you pick an origin other than these 3? By all means, let it be your funeral, not mine. So pick something different. Or no, don't pick something different. Pick something. I choose roughly 99% of the time the lowest point. And in the case of 2D motion, lowest leftmost point. So the leftmost point, the lower leftmost point, the lowest point is C. Now granted, I exaggerated a little bit of the horizontal. There is no horizontal motion, I'm just differentiating the locations. But I picked the lowest point. The lowest point will have a value of 0. And I've chosen Y because I've written out my position equations in Y. Y is most often associated with the vertical. You could pick, instead of Y, you could pick X, you could pick T, you could pick Z, you could pick a drawing of a donut, but as long as you identify what that variable is, it doesn't really matter. Most often we pick Y, so let's stick with that. So if the coordinate at C is 0, question to the class, what's the coordinate of A? What is the Y coordinate at A? 100. Because if that's 0 and that gap is 100, then that coordinate is 100 meters. That is a known coordinate. Do we know, can we readily identify the coordinate at C? And this is a multiple lesson. This is sometimes the answer is, and this is going to, and it's the answer. So what's the answer for C? What's the coordinate at C? For the moment. Oh, I'm sorry. I'm an idiot. I should have said, actually, Wonderful answer, class. Let me ask you the next question. What's the coordinate at B? Don't eyeball me and just sit there and mumble. Eyeball me and give me the answer. And you're actually, congratulations, you're going to be the lesson. So what is the answer? 150, I guess. Is this Jeopardy? Should you be answering this question in a form of a question? I got another question. What do you want to be when you grow up? Physical therapist. So you're going to be repairing people with. My father had both of his knees replaced, and when I told him that I'm going to be teaching for future physical therapists, he was like, "Perfect, working bad." Because basically, if you don't know, when you get your knees replaced, they got to get you up an hour after the operation's done, because otherwise the knee will weld itself closed. So do you want, if you're getting your knee replaced by him, and he's training you, do you want him to just sit there and go, "No, we're going to do maybe"? You want, this is what we're going to do. I'm going to get your knee back in order, and you're going to get it done. That's what you want. You want your pharmacist to be able to know the difference between heart medication and diabetes medication. You want your doctor to know the difference between your heart and your kidneys and be confident about it. Watch this. The answer to that question is elephant. Now, and as you're just eyeballing somebody else, look, keep your eyes on me. I'm not here to kill you. The point of this is Dr. Eschenberg values confidence at this stage way more than correctness. I want students to be confident because eventually you're going to go out in the real world and you're going to need that. So one of the side lessons in this course is we're going to find out who are the confident ones and who aren't. And you need to have confidence for certain jobs. So again, now I'm done with you guys. Let's go over here. Don't look to the side. I've already locked on. What's the answer? What is the coordinate at B? And it's when you hear the answer, you're going to go, "That's a valid answer?" Yeah, that's a valid answer. For the moment, can you readily identify the coordinate for the height at B? Correct. Now, I would love to say for a little more confidence, the answer is no. I have insufficient information at this time. And that is a valid answer in multiple choice questions in my test. So, a little bit more confidence. I understand it's just week 2, but at the end, it's going to be awesome. Now, one of the things that we kind of didn't point out is we've got our origin, pick positive and negative directions. And the origin, I generally mark it with just an O or a 0. It could be either. Because we're dealing with vertical motion, it is sensible to choose up as positive and down as negative. That's what we effectively did when we were picking our coordinates. When I said the valley floor is at 0 meters, what's the height, or what's the coordinate at the top of the cliff? When you said 100, that implied that your coordinate system said up was positive and down was negative. Sometimes we won't do this today, but it's just to get it out there. Sometimes it's best to choose up as negative and down as positive. So sometimes it would be better to choose C as 0 and A as negative 100 in some cases. And since this is just beginning problem solving, we'll go into it more. But for right now, we're just going to keep with this. In 2D motion situations, use only this. It is possible to use different types of labeling for your axes in terms of, you could set up as negative and left as positive, but it really does cause confusion. So when we're using 2D motion, I've never used anything other than this. In 1D motion, it's split between this one and this one, and it really depends on my mood, or sometimes the equations are going to just work out better if you flip your coordinate system. So we have our origin, we have our coordinate system, we know up is positive and down is negative. Also, this is another reason why AY is negative 10. In this situation, gravity is down, so acceleration would be negative 10. In this case, gravity is down, but down in this case is positive. So if you set this up, AY would equal positive 10 meters per second. So that's one of the reasons why I would go back and meet my 17-year-old self and just slap him silly. Because in physics, what is positive and what is negative anyway? It's merely a tool of our understanding to gain a better understanding about the universe. We could set up as negative, we could set down as a positive or negative. It doesn't really matter. The math will work out. Trust me. So we've got our origin. We've picked our positive and negative directions. ID, what you know and don't know with regards to the problem. And this problem divides, and we've talked about it earlier in the lecture. There are two major problems within this problem. The first problem is from launch to landing. A to C. The next part is from launch A to top of curve. Not curse curve, which is B. So in one part of the problem, the ball launches, it goes up, it comes back down, it lands. The other part of the problem, it's launched, it reaches the top, and that's the end of the second part of the problem. Worry only about each problem's start and finish point. And by worry, I mean think only about the conditions at the start and the end of the problem. But what about the middle? Don't care. In this particular problem, the start is at the top of the hill, the end is on the valley floor. I don't care about this. The other part, it launches and it reaches the top. For the second part of the problem, I don't care about this. So there are two major types of problems, and really what we're going to do is we're going to take those 1D motion problems, use them in one way, wipe the slate clean, use them in another way, and then we've got what we're looking for. So the first thing we're going to do is we're going to look at from A to C. And we're going to look at y equals y naught plus v naught yt plus 1/2 ay t squared, and v equals v naught plus, vy is v naught y plus ayt. And what I typically use is, what's really interesting is the first couple of lectures I gave were on the whiteboard in 101, back when this class was only the size of like 40 students. And eventually we moved from 109, which is the small room, to 101, which is the bigger room with 100. And with whiteboards, I have like 10 different colors. And suddenly in the middle of the lecture, I would pick up a new whiteboard marker and I would just hear a whole bunch of this, which was, and eventually I was mystified, turned around and figured out what the class had eventually started to do, 1 by 1 to 2 to 5 to 10 to half the class to almost all the class, is they bought their own set of colored pens, pencils, markers, and stuff like that. Because I am a huge fan of using colors to communicate. There was a lab physicist who demanded that all the students write their reports in blue ink. And when I was the lab physicist for a semester, they said, well, do we have to write it in blue ink? And I'm like, you could use green crayon for all I care. Use all the colors. So in this class, in addition to learning the material, I also expect you guys to learn how to communicate that material to me and to your fellow students. And one of the ways that I use is I use color. Now in this case, if I use a line that, it doesn't matter, as long as, if I use a red line, that means that the variable listed above is unknown. If I use, normally I do this. Red is unknown, green is known. If you're colorblind, let me know later after class and I'll switch the color scheme. But traditionally, I use red and green. Red means I'd have no idea what's going on with this variable. Green means I do know what's going on with this variable. So, considering only A and C as my starting and ending points, and this is what physics does, and I can hear everybody go, oh, this is a long run. With physics, what I do is I take a problem and I painfully go over it step by step. At the beginning, A, at the end, C. Do I know the final coordinate of the motion? Yes or no? Yes, it's 0. Do I know the initial coordinate? Yes, it's 100. Do I know, and eventually it gets to the point where we start forgetting about, well, what was the problem to begin with? Do I know the initial velocity? Yes, it's 30. Do I know what time is? How long does it take for the motion to go? No. And in fact, I don't know because that's one of the questions that I asked. So marked in red. So both of them. Do I know what acceleration of this thing is in the vertical? We're on the planet Earth. It's got to be -10 because down is negative and up is positive. Do I know what my final velocity is? No, I don't know what my final velocity is. Do I know what my initial velocity is? Yes, it's 30. Oh, nope. Go back. Oh, wait, green pen. I know I'm on the planet Earth, and I know that I don't have time as a known quantity. Now let's look at these equations. Let's see, I don't even know what part of the... So in these equations, I've got one equation. How many unknowns do I have in this equation? There are 2. So can I solve for t? No. Could I solve for v sub y? No. That equation is useless to me at the moment. This equation here, how many unknowns does it have? It just has 1. Which means I can solve for time for just this equation. And then that time will be known. Now when you're doing this, the first number that you want to plug in is 0. And I am not a big fan. This is, as I've said before, this is physics and not acoustics. And then, or not, accounting. And then one of my students said, you do have a favorite number. And I was like, how dare you? And he said, your favorite number is 0. And I was like, you're a wise man. 0 just yanks hunks of code out. Just takes equations and make them go away. Why write something if it doesn't really exist? What is my 0 in this equation? Y. The final Y position is 0. Now, this problem was done in this particular way because 0 equals 1/2 AT squared plus V naught YT plus Y naught. And in this particular case, I am going to plug stuff in. -10/2 T squared plus 30t plus 100, or -5t squared plus 30t plus 100. So this can be solved using quadratic formula. And I want to see if I can do something like this. And granted, I didn't realize I was going to need this. Program, quad form. A is -5, B is 30, and C is 100. Okay. And the answers that I get are negative 2.39 and positive 8.39 seconds. So we need to first talk about quadratic problems. In the homework, I've given you about, 9 days, 12 days to get done with the first problem set. So in a situation where I know you guys have 12 days, the problems can be a little bit more involved. Philosophical statement about my view on homework: it is much better to sweat in practice than bleed in combat. And the homework is designed to push the boundaries a little bit, make you suffer, so that when you get to the test, you're like, oh, this is easy. Quadratic equation solving, in my opinion, is just mathematics. I think it's kind of beneath the class, but it is useful in several ways. Will the quadratic equation be necessary to do homework? Yes. Is it okay for you to use? Is there an app for that? Most definitely. You can program your calculators and stuff to do that. I've got an app on my iPhone, and I use it all the time because I've done that equation 5,000 times. I don't need to prove it again. Will the quadratic equation be necessary on a test or final? Answer: no. My opinion of the quadratic equation: it is a time sinkhole. It is not a test on your knowledge of physics. So I try to write the test such that you won't need it. It is possible to use it during a test, but the problems will be constructed, so it's unnecessary. So we've got two solutions. We've got a negative time and a positive time. Which one do we use? We use positive. Negative doesn't quite make any sense. Positive does. So the answer that we need is 8.39. Let me tell you why the quadratic solution came up with a negative time. Now, mathematically, you set that point to be where time is equal to 0. That point is where it crossed that line, 8.39 seconds in the future. Had you stepped backwards in time where the object could move through the mountain, it would have been at that same level, roughly 2.4 seconds before it launched. It is mathematically possible, but it is not physically possible. So we just throw that number out. So the answer that we use is 8.39. Now that we have that answer, the velocity at impact is solvable. Now let me ask you a question just to see if you guys are thinking. Should the answer be positive or negative for v sub y? Should be negative. Why? Because that thing's coming down. If it was going up, it would have a positive velocity. Or if you said down was positive, it would then have a positive velocity. But in this case, we've said down is negative. I know for a fact that this thing is coming down at impact, so it's got to have a negative velocity. So v naught y plus at. V naught y is positive 30, a is negative 10, time is 8.39. So the solution is negative 53.9 meters per second. That's the final velocity at impact. Now, when I first gave tests, there was, if you look at the old tests, which are kind of useless because I've matured as a tester, the front page was very bare, very sparse. Now it's beginning to look like a housing purchasing contract, It's got a lot of things in it, and one of the things is the snark rule. I don't like snark on tests. I promise I won't give any to you on a test. I expect no snark right back at me. I'm in the middle of a story. I'm going to get to you in a second. Some people have gone or have given me the answer, well, at impact it hit the ground, so its velocity is 0 meters per second. Ha, ha, ha. And I'm like, okay, fine. Your score is 0. Right back at you. So what I'm expecting, when I say at impact, I mean the moment prior to it coming to a stop. That's what I mean by that. Who has a question? Oh, you figured that? Okay. So, no snark. I want my answers in meters, kilograms, and seconds, or combinations of that. I don't want furlongs per fortnight. We can get cute during the homework. We play serious games on the test. So because it's a big deal. I'm a big fan of them. So that's the first part. Great, we've now done half of the problem. Let's move on to the second half of the problem. But really, what are we doing here? We are really slowly exploring line by line how to think through problems. If you take this technique right here, you can apply it to any one-dimensional motion problem. Done. What I want you to learn today is the technique that we're using. What we're going to do now is use the same technique to work this problem in a different way. Instead of launch to land, we're going to go from launch to top. We're going to use the same origin. We're going to use the same directions. Up is positive, down is negative. So really what we do now is jump to y equals y naught plus v naught y t plus 1/2 at squared, and vy is v naught y plus ayt. And if you look at the previous problem and look at this one, you're beginning to see the lather, rinse, repeat, the repetitive motion. Once again, we've identified it as a 1D motion. We've rewritten these, and now we're going to grab our red and green pens and mark what we don't know. This is for A to B. I no longer care about the conditions at C for the final point. The conditions for the final point now are at B, and we act accordingly. Do I know my final Y from A to B? No, I have no idea what that is. I do know what my initial Y is. That's 100. I know what my initial V naught Y is. 30, yes. Do I know what my time is? No, I have no idea on time. But I do know I'm on the planet Earth, so AY is known. Do I know and obviously I know my initial Y. Here's the question. Do I know what my final Y is? Yes. What is the value of final V sub Y? It is 0. The object is at the top of the curve. And what was really funny is that half the class just kind of went, what? And the other half was like, no, I got this. So I perfectly expect people to look confused the entire time. It's when the entire class looks confused, when one half of the class looks at the other half and the other half goes, we're doomed. That's when I stop, and then we back up a little and go forward again. So right now, the class is kind of with it. The Vy is 0. In the preceding problem, it was the position equation that had one unknown. and we attacked it. In this circumstance, it's the velocity equation which has one unknown, and we're able to attack that. So this is the equation that we go after. I move this equation over. I divide by A. I plug in. So negative 30 over negative 10 means 3 seconds is the time of flight. The time of flight from launch to the top of the curve is 3 seconds. Now that you know time, this equation becomes a one unknown. The final height is the value we're looking for. So y naught 100, v naught y 30 times 3 1/2 negative 10 3 squared. So 190 should be 145, I think. If anyone does the math and disagrees, call it out. So the height is 145. So what are the steps that we used? We looked at our equations, wrote them out. It's a 1D motion, so we gotta probably have a position equation, most likely have to have a velocity equation. We identify what we know and don't know, and then one of the equations will break down and be a one equation, one unknown problem. So in that last step, it will either one of the equations will have one unknown. And really what I'll do is I'll let you guys know. I can hear you guys kind of rumbling and packing your stuff. And we're not going to leave at 3:45. We'll probably leave at 3:40, a little bit early. I'm a giving God. So really what I'm doing is I'm sitting here, I've got the clock staring at me in the face, and I've kind of got an idea of what I need to cover. So this is going to be the last topic of the afternoon. In these types of problems, it will break down into one of two ways. One of the equations will be like this, a one equation, one unknown. And what you do is you attack that equation first. Or it will be a two equation, two unknown problem. Now what I'm going to do is a simple math problem. Give a little background on this type of problem. Someone tweeted and used my name. I follow my name on Twitter. And she didn't say anything slanderous or anything. She just said, every time Dr. Eschenberg says two equations, two unknowns, I die a little more inside. It's not that bad. Let me just explain how to do it. A two equation, two unknown problem this is a sample two equation, two unknown problem. What's the value of x? I have no idea. What's the value of y? I have no idea. So we have two equations. Each one has the same two unknowns. It's a two equation, two unknown. Once again, little piece dies, fling it aside, keep going. What you do, you look at these equations and you isolate one of the variables. Let's look at this one. This one, it's easy to isolate y. You just move 6x over here. I now have y as a pure expression of x. And then I plug that into here. So 3x minus 2y equals 4 is 3x minus 2. 6x plus 8 equals 4. All I did was substitute the y into x. Next, solve for x. 3x minus negative 2 times 6, negative 12x. Negative 2 times positive 8, positive, ooh, what did I do wrong? Negative 16, thank you. Equals 4. So the negative 2 hits the 6x, becomes negative 12x. The negative 2 hits the positive 8, becomes negative 16. I distributed the negative 2 with what was y. 3x minus 12x minus 9x minus 16 is equal to 4. Move the 16 over, minus 9x is equal to 4 plus 16, or 20, and x is negative 20/9. And I'm going to keep it as a fraction. When you're doing problems like this, if you round, you're snipping bits of information off the number. If you snip sufficient bits of information off that number, your final answer will slowly diverge from the true answer. In programming, it's called bit rot. Little bits of information go bad, and eventually it becomes corrupted completely. Now that one of the answers has been solved, plug it into the other one. The one that you originally used to substitute for y. Y equals 6, negative 20 over 9, plus 8. So it's negative 120 divided by 9 plus 8. And y is negative 5.33 repeat. And so now, let's see, 20 divided by 9 is negative 2.22 repeat. And so that's how you do a 2 equation 2 unknown. So much of Physics 213 is like what I've taught you today. So much of 214 is so much of what I've taught you today. Identify your equations. Identify what you know and don't know. Does it break down one of them into one equation, one unknown? Or does it break down into a slow death spiral with the 2 equation 2 unknown? That's what physics is at this level so far. That's it. I'll see you guys on Thursday.